Yeah, so let's move forward. So that's basically a little bit of summary. And also yesterday, and that's going to be also a good bridge to today, we've been digging into also finding the network traffic, identifying it, but later on we get into the memory dumping, and I was mentioning the injection part. And how to find it, and we were playing with the red line and things like this. Yes. So that injections and the malfinds that we're going to be doing and playing with today, they have a pretty nice way of finding how code could be injected into the process while we are performing the investigation. And therefore, when we are thinking about that, let me just deliver an attack. And as a part of this attack, I'm gonna be just investigating what is happening in the process. So that's gonna be injection that we're gonna be doing as a part of the migration process in the Metasploit. So really injection. And then the next part, it's gonna be to look into the process itself. Yep. So that's gonna be the flavor. Now, let me just get into Kali. We're gonna be using maybe this one. And I'm going to do this from my local environment. It doesn't really matter, but it's going to be a little bit smoother, I believe. Okay, and I got a machine that we're going to be getting access to. And the attack that I will perform, it's simply a relay. Yeah, so the point is that I'm going to be using a relay attack. Because it works everywhere in every infrastructure, unless you've got SMB signed and so on, and unless of course you've got anti-exploitation solutions. So so then this relay is going to bring us to this machine, a process, and that process we're going to be exiting, and we're going to be getting into the SVC host, chosen SVC host. So just a couple of comments here. This would be the machine that we're going to be attacking. And in the meantime, we're going to be leveraging the Kali that I'm going to just bring onto the field. Not that one, but this one. It's already there. Here we go. Okay. So let me just log in, and then our job is going to be to look inside the process. Yep. So as simple as this. Okay. So how would the attack? How it's gonna look like? So actually, let's bring it on like this. So I am already in Metasploit. So this for this one I'm going to explain in a second. So it's here, and I did use exploit multi-handler, and then the next part is set payload, Windows Meterpreter, and then it's going to be reverse underscore TCP. No TCP, of course. Here we go. And then set host. It's a 10.10.10.99, which is my IP address over there on Kali. And set and actually show options, because yeah, the port is 444, which is okay. Okay, and then I'm ready. Exploit. Now on the other console over there, I do Python SMB relay X. This is a part of the in-packet master script, and we've got it -8 10.10 to 50. So we're going to be attacking the host to 50, and on the connection, we're going to be running that shell, and this CQ shell 148.exe. It's actually something that is generated by myself by using our tool, and it's nothing simpler than that. Let me show you. The command line is starting, and we got it here. So this one is when we get into the tools, CQ tools, and then CQURE, no, CLS, and then we get into the CQ reverse shell generator. Yeah, so that's what it is. And then you specify the IP and the port. Yeah, so that's basically the case. And then when you do IP, let's say 10, 10, 10, 99, it's just an example, port 4444, then it generates us an executable. This one, it generates us an executable that is basically a reverse shell. And then you can just whatever rename it or not. And then that's this one here. That's this one here. Yeah, so let's do that. So we are just starting the relay attack, and we are waiting for the connection to the IP so that we can enforce NTLM version 2 authentication, so that we're going to capture the challenge, and then we're going to capture the challenge, of course. We're going to also capture the response, and we're going to take the response and we're going to relay it somewhere to the target. Yeah, so that's basically the case. And our target is this machine. So I'm doing on my other machine the / IP, and this captured the connection, and then we get a stage opened. Yes, so eventually we can get into our shell, and we can of course see what that is, which is a little weird because it's supposed to be a no, not like that. Multi-operator PS. Okay, now it makes sense. Let's just migrate to the process 6x8. Migrate 6x8. Okay, hopefully I manage in time because there's like 15 seconds for the completion. So we will see. We will see that. If not, then we can just regenerate the attack. It's a couple of seconds. Yeah, it takes a little bit of time. So too much. Yeah, session died. That's fine. Yeah, exploit once again. Yeah, let's do that. Session open, and then let's just do migrate 668 immediately. And we are migrating from 660. That was successful. And that 660, where we want to check what that is. Oh no, okay, not here. We can do PS. 660 should be already off. But we're gonna check, of course, what that was and so on. So there was a process, but there isn't anymore. And yeah, we can do shell, and then who am I? And then we are local system, yeah. But that's an attack, yeah. So it's easy. Now in here, what's this? Oh, that's right. In here, we've got our client for the analysis, and over there we can just have a look on the C Windows prefetch, and in C Windows prefetch, you can see what we got. That's basically in here. And you can see that I've been running CMD, who am I, and that X reset or something. It's just a random set of characters, including this one and including this one. It's actually our malicious code. Now, can I confirm on that? Yeah, we will be able to see here the name of the executable. Yeah, so it was just simply there. Okay, so having this in mind, the next part is to basically analyze that, and we are right now in the 668. Now, two things that I want to show you really, yeah, because that's the goal of this demonstration. One is, if you're gonna get into netstat, remember netstat minus a and all pipe more, then basically we've got over there 660, you see, but we don't have 660 anymore. It's not there, but we have 668 as SVC host that we have migrated to, but this guy won't tell you that, so you get stuck. That's my point. So that's why it's always important to make a memory dump, because if you're going to go into the 668, yeah, and then properties, and then we go to the memory. Is it? Okay, yeah, sure. It's my bad. Yeah, here we go. Yeah, and let's go to the 668 once again. Yeah, perfect. Then we don't really have to search too far. It's the RWX. And if you're going to really save this, and if you're going to drop it to the virus total, then it's going to tell you it's a Metasploit, reverse shell, and so on, because it's this type of a code. And you might not see MZ up front, but you may see it here. So the key for this automated tools is to search for that. Yeah, so you can see that that's an MZ. Plus, indeed, you may want to cut it off. Delete. Starting with MZ and so on. Anyway, we get that. But then when you're going to go to memory strings, 25, then over there, you're going to see that it's quite a lot of different interesting messages. But you can see already here that there's like a meterpreter, and then it's more of that, yeah? So because it is a shell that's generated by using the Metasploit, yeah? So eventually you'll be able to find quite a lot of references to the Metasploit as well, yeah? So that's why like when you are generating your own a piece of code, yeah, so your own shell, then it is interesting actually to see what's visible over there, yeah, because this is how others gonna perceive it too, including paths for symbols and things like that. Okay, so just wanted to show you that, doing a little bit of a bridge to that analysis. Now, PS list, PS3, PS scan, PS exview, yeah? So what's the point? The point is that whenever we are analyzing certain memory dump, we already know that we should be searching for things like processes. But in order to be able to search for the processes, you need to, well, know how to do it. Not that you, but in general, we need to have a tool that's going to be aware of how to do it. So we got processes. Yeah, so that's what we normally do when we search for things once there is malware. Yeah, so then we got PS list, PS scan, and so on. So you're like, okay, that's like a process hacker thing. Good. But the problem is that PS list may not always show you things, and the PS scan might show you things in a different way. So when we are thinking about what's the difference, then first let me show you the problem, and then we're going to show the explanation why actually this is the case. So digging in over there, here we go. Let me show you how on the certain memory dumps we're going to be experiencing the difference, like where the difference actually comes from. And for that, I'm going to be just get into Python and then volatility. And I'm going to be using the volatility over there, -F. And if I'm not mistaken, it's going to be tools, dumps, fact, PC. I think so. Okay. And so we got that. And I'm just thinking this would be the dump that's going to be impacted over there. And here we will need to give a profile. And profile, it's the operating system build, which is going to make things a little bit faster. Yeah, so if you're going to do profile, then basically we can get into the Windows 7 SP1 x64. And that's basically a case-sensitive naming of the profile. And then after that, I'm going to do PS list. Let's make it bigger. Let me see if this is this dump, but it's supposed to be. And after some time, we're going to see the output, hopefully, where, of course, we're going to get the process list. When we're going to get the process list. Why it's so I have no idea. It should be much faster, but it's probably because it's just loading that memory dump to the memory. Anyway, we got something. It may not be the one that I've been interested. Let me just see. Enter. Let me just get analyze PC. Hacked PC is interesting because it contains quite a lot of details, but this could be, I think, a little bit better. Yeah, okay, that's even faster. Okay, yeah, perfect, that's perfect. have a look. So we get over there, volatility, and then profile, PS list. That's it. So we get to the details, yeah, and then what's suspicious over there? I mean, I don't know, but what PS list gives you, it's actually some kind of a list, as they call it, doubly linked list, yeah? So what's this doubly linked list? And that's basically a part of the object that we called active process links. And there is an object like that in the operating system. I'm going to show you this in a raw way. And that's active process links. It's just a component that's part of the list. And eventually processes, they point to each other. So it's like a doubly linked, meaning that if you are a new process, you're going to create the link to the previous one, created in time. But if you are old process, all there, yeah, just before the new one, then you're going to create a link to the new one. So we get like, yeah, like this. So when we get to the PS scan, then we're going to get into summary, where we're learning that in the PS scan, we're actually getting malware.exe. Wait, so that shows up in the PS scan, but this does not show up in the PS list. Why like that? Because simply someone modified the list. And this is how you, by the way, hide processes. And I'm saying quote, quote, because people like to say that, but it's not true. You don't really hide things. I mean, it depends how we understand this word, but they cannot be hidden. It's in the memory, they work. So they're not really hidden, they're hidden from something. So they're hidden from the list. Okay, but then I'm going to use a different tool, and then they're not hidden anymore. So they're just not showing through this tool. Yeah, so that's what it is. As I said, I'm completely not romantic. So overall, PS list, that's what it is. Okay.